Let's do another example of law of cosines with SAS triangles. So in this example, let's start with the drawing. You have a triangle, let this be 65 degrees, and this is 9, and this is 7. In this case, let's say that the triangle is not necessarily drawn to scale. To solve this is not necessarily a right triangle, so we're probably going to look to use the law of sines or cosines. In this case, we have a side and an angle and a side. And the angle is in between the two sides, so we call those SAS triangles. And whenever you have an SAS triangle, then you're going to use law of cosines. And the law of cosines has three different forms. And the three different forms are a squared is equal to b squared plus c squared minus 2bc cosine A. And the other two forms are very similar. B squared is equal to a squared plus c squared minus 2ac cosine big B. And then c squared is equal to a squared plus b squared minus 2ab cosine C. And the little letters represent sides and the large capital letters equal to angles. Sometimes what people do is they put a little slash in between the C's so that they can remember that we're talking about sides. This doesn't have a drawing, so it turns out it doesn't have a label system, so you can label it any way you want to. In this particular case, I'm going to label this A, and this B, and this C. And in this particular case, I'm going to solve for this third side, and that's all I'm going to solve for. So let's say solve for, let's say this is big A, so in this case we're going to solve for little a. We have to decide which of these three formulas to use. It turns out that it doesn't matter if you use the wrong one because it won't work, and you can just back up and use a different one. So in this particular case, I have angle A, so I'm going to, at least to start with, assume that I'm going to use the one that has the angle A. And in fact, that's a pretty good assumption. So I'm going to use this formula, and then what I'm going to do is I'm going to plug it in. I go a squared is equal to b squared plus c squared minus 2bc cosine A. Let's see what I have here. I don't have A, but I do have B. So then that's 9 squared, and I have C, that's 7 squared. And that's 2 times 9 times 7. And cosine, do I have A? I do, 65 degrees. And it turns out that at that point, it's just plugging numbers in, right? So let's go through the steps again. First, I recognize that this is a SAS triangle, and I know or memorize that when I have an SAS triangle, I use law of cosines. This one wasn't labeled, so I went ahead and labeled it A, B, and C, and these are the three forms of law of cosines. I choose the appropriate one, though if I choose the wrong one, I just redo it and choose another one. In this case, since I have angle A, I use the one with the angle A in it, and then I just plug in numbers. So let's go ahead and do that. That's a squared is equal to 81 plus 49 minus, let's see if I can do that in my head, that's 9 times 7 is 63. That's 126 cosine 65. A squared is equal to, that's 120, that's 130 minus 126 cosine 65. At that point, I might be tempted to subtract 130 and 126, but I can't because this is multiply. Multiply in PEMDAS. Multiply has to go before subtract. So I just plug that in my calculator. 126 cosine 65. That's about, let's see, cosine of 65 is about 0.4. Let's call it 0.42. 126 minus 130. 126 times 0.42 is, actually got that wrong. Let's try that again. That's 126 times 0.42 is going to be 53.2. I'm going to subtract that. I get a squared is equal to roughly 77. I take the square root of that. Now I'm actually leaving it on my calculator and rounding there, though I'm writing it down for effect. That's about 8.8. And that's how you solve for the side A. Now, to solve the entire triangle, we still need to solve for angles B and C, and that's what we're going to do next. It doesn't matter what order you solve for B and C. You can do it in any order you want to. Let me solve for B first. If I'm going to solve for B, I think that I'm going to use the formula with the angle B in it. Let's see if that will work. That's B squared is equal to A squared plus C squared minus 2AC cosine B. Let's plug things in. That is 9 squared, 8.8 squared, plus 7 squared, minus 2 times 8 times 8, times 7, cosine, and B is what we don't know. Now I have some calculator work to do. 8 times 8 squared is about 77. So 81 is approximately 77.4 plus 49. 8.8 times 7 times 2 is about 123. You can always, if you're doing your calculator, you can always say if that's about right. Let's see. 9 times 7 is 63, and twice 63 is 126. That looks about right. And now everything else I just plug in a calculator. I go 77.4 plus 49. That's 126.4 minus 123. Cosine B is about equal to 81. I have to subtract 126. Subtract 126, and I get minus 123 cosine B, and I get 81 minus 126.4. That's about minus 45. When I divide, I get 45 divided by 123. It's about 0.37. It's equal to cosine B. Now at that point, I have cosine B is equal to 0.37. So what I'm going to do is go cosine inverse. Cosine inverse of 0.37 will give me B. It'll be an approximation. 0.37. That's going to give me roughly 68 degrees. And that's how you solve for angle B. If we go back to our original drawing, we knew that this was 65. That was A. This is B. That's 68. We were given that B was 9, little c was 7. We solved for angle A was 8.8. Now, if this angle is 68 and this is 65, let's add those together. That's 8, 9, 10, that's 13, carry a 1, 12, that's 133. Now, if these three angles together add up to 180 and this is 133, then you just subtract 10, 7. 7 minus 3 is 4. That's 47. So the last angle is 47. Now you're done. You've solved for everything on the triangle. And that's how you do law of cosines when it's an SAS triangle.